Lesson 11-8, Graphing Transformations. And in this lesson, you learn to graph transformations on a coordinate grid. When am I ever going to use this? Knowing about transformations can help you do computer animations. Okay, words that we are going to learn: transformation, translation, and reflection. Okay, so the Zapotec engines in Mexico weave colorful tapetes. Tapetes are used as rugs and wall hangings, just like the one that you see on the right. A transformation is a movement of a figure, so that's a general definition of a transformation. It's a movement of a figure. So what kind of transformations do you see in the design of the tapete? Okay, so in the next activity that we are going to do, it's named the hands-on lab. You learned about two kinds of transformation: a translation and a reflection. Okay, so basically, when you slide a figure from one location to another without changing its size or shape, the new figure is called a translated image. So when you slide a figure from one location to another without changing its size or shape, we call that a translation image. Okay, so that's the definition of a translation. When you flip a figure, so there's another definition. So when you flip a figure over a line without changing its size or shape, okay, the new figure is called a reflection image. So the size and shape doesn't change. If you slide it, it's called a translation. When you flip it, it's going to be called a reflection. There are other types of transformations, but these are the only two that we are going to talk about for today. Okay, so this is what we need to do in our hands-on activity. Okay, you want a grid paper. Okay, you want graphing paper for this one, and you want to follow along, because as you do this hands-on, the better you will understand this. So try this on grid paper. Draw a coordinate grid like the one that you see, and then we graph points A, negative 2, 3, that's negative 2, 3, negative 1, 1 right here, and negative 3, 1 right there for point A, B, and C. So we now have triangle ABC once we connect all those points. So on a separate sheet of paper, trace triangle ABC and cut it out. So you want to do that. If you're following, then simply pause this and do that first. Okay. Place the cut out triangle on triangle ABC. So after you cut out, get the cut out piece of triangle and place it on top of triangle ABC. Okay. And then we want to slide the cut out triangle 5 units right. Okay, and then label the new vertices A prime, B prime, and C prime. Okay, then we want to draw a triangle A prime, B prime, and C prime. Okay, so the notation A with an apostrophe is read as A prime. Okay, A prime is a point related to point A. So that's the reason why it's called A prime, because it's a point related to point A. Okay, so again, we want to slide the cutout triangle 5 units to the right. Okay, uh, and in order to do that, since I'm not cutting out the triangle, what I'm going to do, since it's saying slide it 5 units to the right, it also means that we move all the points 5 units to the right. So if we move point A 5 units to the right, this will be 1, 2, 3, 4, 5. This will be A prime right there. B 5 units to the right, 1, 2, 3, 4, 5. This will be point B prime, point B prime. And C 5 units to the right, 1, 2, 3, 4, 5. And this will be our C prime. And we simply connect our points. Okay. And this is our new triangle A prime, B prime, and C prime. Okay, so what are the coordinates of A prime, B prime, and C prime? Okay, so if you look at A, that would be 1, 2, 3, and 3. B would be, B prime would be 4 and 1, and C prime would be 2 and 1. So those are the coordinates of our triangle. 3, 3, 4, 1, and 2, 1. Okay, so what can you say about triangle ABC and triangle A prime, B prime, C prime? Well, triangle A prime, B prime, C prime is a translation of triangle ABC. Okay, so why? Because we simply slid triangle ABC to the location of triangle A prime, B prime, and C prime. Okay? So let's take a look at this example. Example number 1, the vertices of rectangle DEFG. Okay? D is negative 2, 3. Point E is negative 2, 1. Point F, negative 4, 1. Point G, negative 4, negative 3. So on the coordinate grid, draw a rectangle DEFG and its translation image that is 5 units to the right and 2 units up. So first things first. First thing we need to do is draw on grid paper. Okay, draw a coordinate grid like what you have there. Second thing we need to do is graph and label the vertices of rectangle DEFG, and we'll do that now. Make our line thin again. Okay, so we have point D is negative 2, 3. Negative 2, 3 is right there. That is point D. Okay, and point E is negative 2, 1. Negative 2, 1 is right there. Point E. Okay, we have point F as negative 4, 1 right there. Point F. And we have point G is negative 4, negative 3 right there. It's point G. So from there, graph and label the vertices of triangle DEFG. And then next, draw a rectangle, sorry, not triangle, rectangle DEFG, and that's what we're going to do now. We simply connect those 4 points. Okay, that's our rectangle DEFG. It can be straighter, but we're good to go. Okay, so next, after drawing our rectangle DEFG, we need to translate each vertex 5 units to the right and 2 units up. So every point we need to move 5 units to the right and 2 units up. Okay, so the coordinates of the new vertices are as follows. Okay, so let's move that point O, 5 units to the right, 2 units up. 1, 2, 3, 4, 5, 2 units up. 1, 2. Okay, that's O prime. Oh no, sorry, that's D prime. My bad. So 1, 2, 3, 4, 5. 1, 2. This is G prime. Okay, 1, 2, 3, 4, 5. 1, 2. This is E prime. And 1, 2, 3, 4, 5. 2 units up. This becomes F prime. Okay, and then we simply connect our dots, connect our points. Okay, and that is our new rectangle. The lines could be straighter. So those are the new vertices of our new rectangle D prime, rectangle D prime, E prime, F prime, and G prime. 3, negative 1 for D. Okay. D prime is 3, negative 1. Why is it 3, negative 1? Okay, this doesn't work. Let's take a look at example number 1. The vertices of rectangle DEFG are point D, negative 2, 3, point E, negative 2, 1, point F, negative 4, 1, point G, negative 4, negative 3. So on a coordinate grid, draw a rectangle DEFG and its translation image that is 5 units to the right and 2 units up. So first thing we need to do is on grid paper, draw a coordinate grid like what we have here. Then second step, graph and label the vertices of rectangle DEFG. So we know that point D is negative 2, 3, negative 2, and negative 3 right here. So this is point D, okay? And we have point E as negative 2 and 1. Negative 2 and 1, this is point E, right there. And we have point F as negative 4, 1. This is point F. And G as negative 4 and negative 3 right here. Okay, so after we label the vertices of rectangle DEFG, we draw rectangle DEFG, and this is what we get. Okay, so we draw DEFG rectangle. Oops, let me redo that. We simply connect all those points, so we can draw rectangle DEFG. Okay, so after drawing rectangle DEFG, we translate each vertex 5 units to the right and 2 units up. So basically, we're moving the vertex 5 units to the right and 2 units up. So let's do that right now. Moving 5 units to the right. 1, 2, 3, 4, 5. Okay, so let me do that with point E. 1, 2, 3, 4, 5. 2 units up. So this is E prime. Okay, and let's translate point F. 1, 2, 3, 4, 5. 1, 2. This is F prime. And translate point D. 1, 2, 3, 4, 5. 1, 2. This is D prime. And then you translate point F. 1, 2, 3, 4, 5, 1, 2. And this is F prime. Okay? And then from there, you simply connect all those points with a straight line. Right there. Okay, let me make that last line straight. There you go. Oops. My gosh. One more time. There it is. Okay. So we now have the coordinates of the new vertices are 3, negative 1. Okay. 3, 3. 1 and 3 for F prime. Okay. And G is 1, negative 1. Okay. So label the new vertices F prime, E prime, D prime, and G prime. The new rectangle will be rectangle D prime, E prime, F prime, and G prime. Okay. So that is how you translate that rectangle 5 units to the right and 2 units up. Okay. Next, this is a geomirror. Okay. A geomirror is a plastic mathematical instrument where if you place the geomirror on a particular figure, it shows its reflection. So if you notice in this case, if you draw this part of the star, okay, only, and you put a geomirror on top of it, you can actually draw the other half of the star exactly, because it draws a reflection, okay, of an image. Okay, and if you don't have a geomirror, don't worry about it. Okay, but it will help us aid it. This is the only lesson you're going to use this, so I'm not requiring you to get one. So on grid paper, draw a coordinate grid. Graph points negative 3, 2, 0, 3, and 0, 1. Those are points R, S, and T. Connect the points triangle RST, like the one that you see here in blue. Okay. Place a geomirror on the y-axis. So this is your y-axis. Draw the reflection of triangle RST. Okay, you can see the other side of the y-axis. So basically, if you get that geomirror and you put it on the y-axis right here, you can actually draw a reflection of the triangle, and this is how it's going to look like. Okay, so the reflection would be another triangle. Okay, but this time it's going to be, this is how the triangle would look like. Okay, it is now a reflected image. Okay, let me make that straight again. Now one, okay, that one. So what you have now is a reflected image of triangle RST after you put the geomirror on the y-axis. Okay, so what are the coordinates of r prime? This is now r prime. Let's label them r prime, and this now becomes s prime, and this is o prime, or sorry, t prime. Okay, what are the coordinates of r prime, s prime, and t prime? Okay, so the coordinates are given. Where are the coordinates? Oh, it's in the margin. It didn't get the margin. So the coordinates of those r prime is 3, 2. So r prime is 3, 2. Coordinates of t prime would be 0, 1. Okay. And the coordinates of s prime would be the same as point S, which is 0, 3. Okay. So what can you say about triangle RST and triangle R prime S prime T prime? Triangle R prime S prime T prime is a reflection of triangle RST. Okay, how is using a geomirror like flipping the piece of patty paper? Basically, you can use patty paper, trace this up, then cut out that patty paper, and if you notice, what happens is that you are flipping the figure over the y-axis. So basically, when you flip the piece of patty paper, you are getting the reflection of that image. Okay, and let me show you another good example of reflection. So using GeoGebra, for example, let's say you want to reflect an image, and let's just make this grid. Let's make this full page right here. Okay, so let's say I want to reflect, okay, this little sticky figure, with big feet and weird hands. So I want to reflect that figure, okay, over a line. Let me draw my line over this one. This line right here becomes my line of reflection. This is basically your geomirror. Okay, so if I am going to reflect this figure over this line of reflection, okay, look what happens. It is just flipping the figure over that line. Okay, so I choose my stick figure and my line of reflection, and there you have it. Okay, so the figure simply flips. Okay, if you flip that figure, it is exactly the same figure on the other side. So this figure right here is the reflection of that figure, and that's how a geomirror helps, and that's what a reflection is. It is a mirror image of a particular figure. Okay, so going back here, that's what a reflection is, and let's take a look at example number 2. The vertices of parallelogram W, X, Y, and Z are point W negative 2, 1, X negative 1, 3, Y 4, 3, and Z 3, 1. So on a coordinate grid, draw a parallelogram W, X, Y, Z and its reflection image over the x-axis. So how do we do that? Let's do our parallelogram first. W is negative 2, 1. Negative 2, 1 is right there. It's W. Okay. We have X negative 1, 3. Right there. This is X, point X. Y is 4, 3. Right there, that's point Y. And Z is 3, 1. Right here. Okay? And so we connect our points with a straight line. So point X, point Z. Sorry. point Y, and point Y to point Z to point W, and point W to point X. That is our parallelogram. And so we want to reflect this image over the y-axis. Now we're not using a geomirror, so what do we do? Remember, it's simply flipping the figure around, so these are the steps that we need to take. First, on grid paper, draw the coordinate grid. We're done. Okay, graph and label the vertices of a parallelogram WXYZ. That's done as well. Okay, draw a parallelogram WXYZ. That's also done. So this is our next step. Reflect the parallelogram by flipping it onto the other side of the x-axis. But how do we do this? Okay, to be a mirror image. Okay, this is how you do it. To be a mirror image. Okay, each new vertex must be the same distance from the x-axis as its corresponding vertex. What does that mean? That simply means that if you look at point W, and this is your x-axis, point W is 1 unit up from the x-axis. That means, okay, if it's 1 unit up, okay, W prime should be 1 unit down as well. So this becomes W prime, this point right there. Okay, and look at point X. Point X is 1 to 3 units from the x-axis. That means point X would be, if you reflect it over the x-axis, will also be 3 units down. So this is point X prime. And just like Z is 1 unit up, Z prime would also be 1 unit down, and Y is 1 to 3 units up. Okay, so it should be 3 units down as well. So 1, 2, 3 for Y prime. Okay, and all we need to do is connect those points again with a straight line. Okay, point Y connects to point, what's my other one? Z prime, right there. Okay, and oops, not straight. Let me make that straight. So point W prime connects to point Z prime, and the Z prime connects to Y prime. Y prime connects to X prime, and X prime connects to W prime. So you notice that you now have a mirror image of the parallelogram WXYZ. Okay, you've basically flipped it over the x-axis. Okay, so the new coordinates are these: -2, 1, -1, -3, 4, -3, and 3, -1. So we label them as W prime, X prime, Y prime, and Z prime, and you end up with, if it shows up, okay, the parallelogram W prime, X prime, Y prime, and Z prime. Okay, and the secret word for this particular lesson is dark. Secret word is dark. Thank you for watching.